Do you want to know why deep fundamentals matter and why they're your most transferable skill in tech? If so, this video is for you. In today's video, we're going to discuss why deep fundamentals matter so much and why they are the key to success for cloud architect careers, security architect careers, and any other IT architect. When I started my career, things have changed a little bit, or have they? But yesterday it was virtualization, then it was cloud, then it was containers, then it's service mesh, then it's zero trust. I mean, it constantly feels like a state of evolution. But if you take some of the noise away, a lot of people really feel about the same thing, that if I don't learn this right now, I'm going to fall behind. And I see this from so many people. They're so worried about learning the new thing and falling behind. But today I want to give you an antidote to that anxiety. Deep fundamentals are going to be the most transferable skills in tech, especially for cloud architects, enterprise architects, security architects. And here's the reason. Your fundamentals don't expire when the tool changes or the name changes. Now, if you've ever felt that whiplash, if I need to learn this, I need to learn this, I need to learn this, comment fundamentals in the chat so I know that I'm talking to people just like me that have experienced this in the past. So what do I mean by deep fundamentals? When I say deep fundamentals, I don't mean trivia. I don't mean the vocabulary. I don't mean which boxes to click. I mean the core ideas that are going to show up in nearly every system. How networks behave, things like latency, throughput, failure modes, identity and access management, encryption, segmentation, micro-segmentation, consistency, availability, observability, change management, risk management, those kinds of things. Because when you really look at it, those fundamentals are kind of like the physics of what we actually do as architects. And the point is tools come and go. It used to be ISDN and frame relay, and now it's kind of an Ethernet or a VPLS world or MPLS-based circuits or Ethernet layer 2 circuits. But vendors rename things. I mean, a lot of the old technology just gets rebranded over time. But that kind of physics, those fundamentals, tend to not change very often. It's only the marketing names that do. And I can tell you, after being an enterprise architect for decades, I can tell you the people that rise the fastest often aren't the ones that memorize a whole bunch of features and chase a whole lot of certifications. They're the people who truly understand what's happening under the hood in these systems and in the business. And that way, when you know what's going on, it becomes so easy to adapt to everything. The secret to the new tech is often the old tech. It just looks a little different. And there's actually an old legendary internet document called RFC 1925. And it's the 12 networking truths. And it's humorous internet specification or request for comments, but it's so accurate. And here's the thing is a lot of the new technology is really the old technology with a new name. I'll give you some examples. It's old patterns with modern packaging. It's the same old constraints, but we now have new interfaces. It's an old problem, but with a new dashboard. It's changed very little. For example, approximately in 2000, Cisco had something called NetFlow that would show you the type of traffic that was traversing your network. Now, AWS has that same service right now in 2025. At the new AWS reInvent in December 2025, AWS announced an interconnect where basically they have a connection to Google and you can just provision a private line on that or a private connection or a virtual private connection. Now that's not that much different than the frame relay networks in the 1990s or the ATM networks or the VPLS networks or any of these networks that existed. And when you know the old thing, learning the new thing is so easy because you're not starting from zero. You're mapping what you know to something that's changed a few percent along the way, and that's going to make it real simple. And that's the power of fundamentals. They give you a mental model that will survive any generation of technology. So 20 years later, in many cases, those same fundamentals still apply. So I'll give you an example for cloud architects, then I'll give you an example for security architects. Now, let's say we've got someone that tried to be an architect and learned engineering, and they became obsessed with tools. and they became an expert of a tool and configuring the tool, even though that's more engineering work. But let's say they did that. The tool-focused person is focused on which button do I press? How do I use this tool? But a fundamentals-focused architect, for example, says, tell me the outcome that we need, what the constraints are that we have, and what trade-offs we're willing to accept. And from there works backwards. So it's very different. Because we cloud architects, when cloud architecture is not about memorizing services, security architecture is not memorizing services. It's about designing systems that behave the way the business needs to give that business a competitive advantage. So for the cloud architects out there, once you have the fundamentals, which in most cases are the data center fundamentals, because all cloud computing is a virtual data center, you can pretty much walk into any technology and figure out real quickly what problem is it solving, what does it do in an abstract way, what does it not solve? What are the sharp edges on this technology we have to be careful about? What happens when it's going to grow at scale? And that's why deep fundamentals will make those cloud architects so adaptable from one role to another role. Because we don't freeze when a technology gets rebranded. We don't fall apart when yesterday's best practices change because our fundamentals are strong. We understand the underlying mechanics. And if you think this is funny, I kind of liked in RFC 1925, one of the statements is it has to work. And that's basically the job description of architecture in some way, shape, or form, at least from the technology perspective, not the business side. Now, the business side has to work too. So let's talk about security architects and where fundamentals help them. Security is a great example because in many cases, attackers don't care what your cloud on. They don't care which vendor you bought from. They don't care. They don't care what acronym is trending. They exploit fundamentals. Weak identity control, bad segmentation, over-provisioned access, broken assumption, unobserved changes that when they try to break into the system, poor key management, and of course, human behavior. So if you're a security architect and you have deep fundamentals, new security tech becomes very easy because you probably already know it. And you have to look at it. What trust boundaries does this change when you've got a new technology, for example? What does this do to the blast radius? What's the failure mode? What's the operational burden? And what risk does it solve? And how is that going to help our organization after evaluating all trade-offs? So you see, as a security architect, these deep fundamentals are going to help you too, because you're not going to be focused on shiny tools. You're going to be protecting organizations and keeping them safe. Now, let's talk about deep fundamentals being your protection against AI for any technology professional. Now, cloud architects, enterprise architects, and security architects tend to be immune from AI-related layoffs because of the stakeholder management, the leadership, and the people work that we do. But still, let's stay way ahead of the curve, and your fundamentals help you stay better than AI. And here's the reason. AI is pretty good at a lot of things. It can generate configs, it can explain concepts, it can help you write a policy, summarize a log, and give you a lot of options very fast. But here's what AI can't do. It can't give you sound judgment under uncertainty. And the reality is when we have real heavy-duty engineering or any kind of heavy-duty cloud architecture, enterprise architecture, security architecture, most of the time the information we have is incomplete. The logs may not be telling the whole story. We've got teams that are disagreeing with each other. The right answer isn't going to be based upon any technology. It's going to be based on risk tolerance, budget, timelines, customer impact, so other things. And when you have to make a decision and be accountable for it, those deep fundamentals are going to help you problem solve in a huge way, and they make you better than AI. So they keep you safe, and they keep you getting promoted, and they keep you from getting replaced in any way, shape, or form by AI. So I really want to talk about challenging and unexpected sort of environments. So I remember at one point in my life, I worked in the ER. Part of that, I was a paramedic. And when you're in challenging environments, you have to be really good at what you do because things get really hard. So here's the harsh truth. A lot of people look smart when things are easy, when there's a playbook that covers it, when the problem is familiar, when the system is stable. Lots of people look great in those times. But what happens when they're not? And that's where the fundamentals are going to matter so much, because the fundamentals are going to ask you a way to go from a big, vague problem and narrow it down to know exactly what it is. To be able to generate a hypothesis. Okay, it could be the network. Is it network latency? Let's test it. No, it's not network latency. Is it network throughput? Okay, let's test it. Is it the CPU? Okay, let's test it. Is it the DRAM on the server? Let's test it. Is it the performance of the block storage an issue? Let's test it. So we can create strategic hypotheses and then test them in the same way a McKinsey consultant would create mutually exclusive, collectively exhaustive hypotheses. But you've got to have good fundamentals to do that. And that also gives us a way to communicate when everyone else is spiraling around. And this is where careers are made. In the hard times, not on the perfect day when things get tough and you are there to save it. So fundamentals are how you understand changes in the system. So if you make this change, what's the impact on another part of the system? And modern systems are complex. And that kind of complexity means if you make a change here, it can easily impact so many other things and create big effects. So you have the ability, when you've got good fundamentals, to plan it. What happens if this route changes, for example? What happens if you change an IAM permission? What happens when you add a new dependency? And your fundamentals will enable you to figure that out. I like what they said in RFC 925. It's a really funny RFC. You can find it on the Internet Engineering Task Force webpage if you want to read it. And they basically say it's more complicated than you think. And that's not pessimism. It's reality. When we get big, when we get at scale, deep fundamentals will help you predict changes and how they ripple through the system. They'll help you understand what happens when you connect things. They'll help you see where the bottlenecks are going to form. And they will help you design for failure instead of hoping for success. So I really want you to truly focus on developing deep fundamentals. So it's going to get you closer. So I don't want you to feel overwhelmed in the need to develop deep fundamentals. You just need a consistent loop. Pick one fundamental. I don't care what it is. Maybe it's BGP if you're a networking person. Learn the concepts. Apply it to whatever you're designing right now, or think about it. Explain it to someone else, and that will reinforce your fundamentals. But make sure you understand it before you explain it. And those fundamentals, when they're part of you, it's something that you'll have forever. So maybe make it a fun challenge. Once a week, read something foundational, an old paper, an Internet Engineering Task Force, RFC, a modern guide on various components of architecture. And that's basically how you're training to be better. We're training pattern recognition. We're training to be more adaptable. So if you take nothing else from this video, deep fundamentals are probably your most transferable skill in tech, because technology rarely reinvents itself. It generally ships new versions of old ideas, just like in RFC 29. Now, I want to hear from you. Tell me what the one fundamental skill you want to work in the comments section. Is it networking? Is it identity and access management? Is it network security? Is it security fundamentals, distributed system, observability, FinOps? Tell me the one set of fundamental things that you want to learn in the chat box. I'd like to hear from you. If you're enjoying this video, please give it a like, subscribe to our channel, and hit the bell to be notified of new videos to assist you in your architecture career. And I have a free bonus for you. Twice per week, we run an architecture webinar where we'll go over what we do as architects, the skills you need as an architect, how to become an architect, and everything that you should do to go from wherever you're at, and I mean wherever you're at, to your first architect job, whether that be a cloud architect, security architect, AI architect, or enterprise architect. And you can register for those free architecture webinars. The link is in the description of this video. Also in the description of this video are guides on how to become, say, an artificial intelligence architect, or how to become a cloud architect, or other things. How to win on the interview, for example, for an architect role. So please stop by the description of this video, download some free things, and hope to see you in a webinar. So this is Mike Gibbs signing off for now, and I hope to see you in another webinar or another YouTube video. Take care.